So section 5.4 is on two main things, centroids and orthocenters. Just like circumcenters and incenters, they have special properties. Okay. So the centroid has to do with the medians of the triangle. Okay. A median is a segment that goes from a vertex to the midpoint of the opposite side. So the centroid is the point where the medians intersect. It is considered the center of gravity of a triangle, and it is 2/3 the distance from the vertex to the midpoint of the opposite side. So what does that look like? In a triangle. So if we go back to my triangle up here, okay, what it means for the centroid to be 2/3 the distance from the vertex means that of this line, 2/3 of it is on the vertex side and 1/3 of it is on the other side. So this segment right here, from the vertex to this point, the centroid, is twice as long as from the centroid to the side. This is exactly twice as long as this. This, from the vertex to the centroid, is twice as long from the centroid to the side in all three of those medians. So a lot of what we're going to do dealing with the centroid is we need to recognize that our three segments that they have drawn into this triangle, we need to be able to recognize what's special about them. So what they're giving us is that this segment XA is congruent to this segment AZ. That means that A is the midpoint. YB is congruent to BZ, so that B is the midpoint. And XC is congruent to CY, so C is a midpoint. So we have three segments that go from a vertex to the midpoint of the opposite side. So we're dealing with medians. If we're dealing with medians, we're dealing with the centroid. The information that we're given is that XA measures 8 units. What is the length of XB? Now, what you need to keep in mind is that if we are dealing with the centroid, the length from the vertex to the centroid is twice as big as the length from the centroid to the other side. So if the longer portion is 8, the shorter portion is going to be 4. The question is, what is the length of XB? So we have to identify what is XB. So that's that whole thing. So the measure of XB is 12. So if we broke that whole thing, XB, into 3 pieces, 3 even pieces, they would each be 4, right? So we'd have 3 even pieces of 4. And 2 of them are going to be between the vertex and the centroid. 1 of them is the other side. So that's why this side is twice as much as this side. So the 2/3, 1/3 part really only comes into play when you have the whole segment. Then you would divide it into 3, like XB. If we were told that we were told that XB is 12, to figure out what the pieces are, I would divide by 3, and the little part would get one of those pieces of 3, which would be 4, and the other part would get the other 2. So in an obtuse triangle, your altitude is going to be outside the triangle, okay? In example 2, we're looking at a triangle and determining whether a given segment is a median, altitude, or neither of those things. So we're looking at triangle PQS, and in part A, we are determining whether PR, line segment PR, is a median, an altitude, or neither. So there's PR. So is that a segment that goes from a vertex to the midpoint of an opposite side? No. Is it a segment that goes from a vertex perpendicular to the opposite side? It's perpendicular, right? And this is our opposite side. So PR, line segment PR, is an altitude. QT. QT goes from a vertex to the opposite side. And we are told in this diagram that those two segments are the same, which means T is a midpoint, which makes QT a median. So an altitude, you were looking for perpendicular. A median, you are looking for equal segments where it meets.